Hi guys, today we're going to be talking to a very well-loved astrophysicist called Anna. Hello Anna. This was an interview with an astrophysicist. So Anna, could you please tell us a little bit about what you do here at Manchester and as a role as a scientist?
So as a scientist, that's easier to answer. So I focus my research on the intersection between artificial intelligence and astrophysics. Astrophysics has very specific requirements when it comes to analysis. It's an interesting field of physics because it's entirely based on inference, by which I mean that we don't set up our own experiments. Like if you want to know something about a star, you can't go up and change the orientation of the star and look at it again. You can't change the temperature and look at it again. So you only get the data that is sent to you. So understanding how the universe works is something that we do without being able to fiddle with it, right? Which is different from a lot of other experimental sciences. So how we do the analysis for that is very specific. And so the artificial intelligence we use to help us to process the vast quantities of data that we receive has to fit the problem very specifically. And so I developed the kind of very specialized artificial intelligence that we can use for astrophysics.
Brilliant, thank you. Now, I am someone who's been blessed as someone who's been lectured by Anna. Do you want to tell us a little bit about what it's like lecturing at the University of Manchester?
Yeah, sure. It's terrifying. There are so many students. They're so smart. Quite intimidating, but it's also really rewarding. I think it's quite unusual compared to other universities, especially in physics. The Department of Physics at Manchester is very large. We have a very large number of students. We have very specialised lectures. And so it's a challenge, but it's nice to hear that it went well.
Absolutely, yes. I mean, once we started this initiative, I was like, I have to have a conversation with you. I could just make this entire interview just fangirling it.
No, I mean, please.
I mean, it's unprofessional, so we'll stop. We'll move on to the next question. Now, this is a time for you to go. When researching you, you have so many things to be proud of. Is there one that you are particularly proud of and want to share?
No. I think in general, as in career-wise, the things, I'm not sure they'd appreciate being called things, the things I'm most proud of are my students, because I think those are the things that I have helped to shape most beneficially during my career. In terms of my actual scientific achievements, I have no idea. And it's very difficult to know, right? Because often you don't know what the best thing you did is until, well, quite frankly, in science, until after you're dead. So there are things that I have enjoyed more than others, but I'm not sure that I could pick something that I was proud of more than anything else. Yeah.
Okay.
Yeah.
I suppose that means that you're equally proud of all of them, which is also nice.
Yeah. Also, I have a long list of things that I'm really not proud of, but I'm not willing to share those.
So no worries. We don't need to ask about those. In terms of your specific field, so I understand that you work with artificial intelligence. Is there something that you're hoping for the field to achieve in the future that's not far from now?
Yeah, so I think in the near future, there are some quite specific things that I'd like to see realised scientifically in astrophysics. I think we're very close to understanding what's known as the epoch of reionization, which was the point in cosmic history when the first stars and galaxies were born. And I think that that's going to be an absolutely pivotal stage in the history of astrophysics, understanding that. And it will probably be done with some of the telescopes that I've worked with. So that's my tenuous connection to it. But I think that's going to be the big thing. It's like it's the CMB of today. From a scientific perspective, that's definitely the thing that I'm hoping will get done before I retire. More generally, I'd like to see the field evolve further. So the kind of research that I do is much more on the technical side of astronomy and radio astronomy. And I think that historically that hasn't been well enough recognized scientifically. Not my work personally, but the field generally, the technical and computational contributions that people make to science. People focus very much on the big science result, the one that makes the splashy headlines in the papers, and they forget about all the work that goes into that. And history tells us that, in fact, where women are involved in science, they're more likely to be involved in the technical side. But it's also why they get wiped out of the history of science, because that technical side is not so recognized. So I think we are heading in a direction where those contributions are more widely recognized. And I think that AI and computing has been important for that, because people are now interested in what makes AI tick. And that has widened the question of, how does all of this science happen? So I'm hoping that that's a general evolution of the subject that we're going to see.
Now, I remember you saying, I think you mentioned it in a lecture or a video, that you said that you didn't always think of a future in physics. How did you come about a future in physics then?
Completely by chance. I was not one of those people who knew what they wanted to do from a very early age. For a long time, when I was very young, I wanted to be an archaeologist, mainly because I think I wanted to be Indiana Jones.
Oh, wow, yeah. That says it all, with that hat.
Exactly,
yeah,
exactly. Right, yeah. I later found out that the Indiana Jones movies were perhaps not representative of what a career in archaeology actually entails. And without that, I didn't know what I wanted to do. So I just did what I was enjoying at the time. And I had a very good physics teacher and a very good maths teacher at school. And so I thought, well, this is all right. I'll do more of this. And so I applied for physics.
So then you fell in love.
Yeah, well, actually, yes. Yeah, I guess so. I just kind of enjoyed it enough not to do anything else, if that makes sense.
Yeah.
Yeah, like lots of people tell you about that deep-seated passion for physics and, how it inspires them every day. Mainly, I just like doing it. And so I keep doing it.
Doing your passions, that's what's most important. Okay. With passions, though, and whatever you do in life, you're bound to come across certain challenges. Have you, from when you decided to take on a career in physics, faced any challenges, whether it's specifically due to your gender or not? How have you overcome those?
So I will start by saying that I don't think that I personally have had to face any very, very significant challenges, not like the challenges that I've seen other people face. And I do hear awful stories from other people about things that they've had to overcome, and it makes me feel very lucky that I didn't have to. I went to university down south for my undergrad. My first challenge was people verbally objecting to my hard A's.
Okay.
So for those people who may not know what this means, I asked someone to pass me the salt in a university refectory, and they turned around and said, "Can I watch you the salt?" "Oh, you mean can I pass you the salt?" Yeah, it's interesting, right? These little niggly things. But I think it's actually quite reflective of the general challenges that you face day to day. As a woman in science, or I think in many careers, a lot of the challenges you face are not the big ones, right? The big ones do happen, and that's a different case. But the small things that sort of chip away at your everyday, and it's the continual addition of those small things that just become problematic. And many of these are things that aren't even particularly addressed towards women specifically, but they cause problems for women because women are disproportionately affected. So caring responsibilities. So the problems that face people with caring responsibilities disproportionately affect women because women disproportionately take on caring responsibilities. And those can be, small things like people trying to schedule meetings out of hours when you can't do them. They can be structural things, like, for example, the university nursery only being open till 5:30 when teaching runs till 6 o'clock. There are lots of these small things that eat away at your reserves in terms of your energy, but also in terms of your time. And I think in research, that's very interesting because things that take away from your time during the working day, you have to compensate for outside working hours. And if you have caring responsibilities, you don't have time outside your working hours. And so the things that will get disproportionately affected are the things that you have the most control over, which is typically your research time. Your teaching and your administrative burdens get done, and then your research gets chipped away. And your research is what your career depends on. And so when you talk about challenges that face women, particularly in academic science, this, I think, is a really unacknowledged problem, which is to do with the way that workloads are distributed.
Yeah. It's the little things that add up. Absolutely, yeah.
And it's very difficult to quantify it as well.
Yes.
Because if someone turns around to you and says, well, what was it that prevented you doing this? You can't point at a single thing and say, it was this.
Whilst we're talking about difficulties, is there anything that you could maybe suggest to anyone watching this as to how they might be able to overcome such challenges?
So I think one thing I would say, particularly to women, is that it's a good idea to learn how to say no to things early on. I think that people have a propensity to agree to things, and you assume that the more you do, the more recognition you will get. And I don't think that tracks. Understanding your own priorities very clearly, and then being a bit brutal about prioritizing those things is probably the best way forward. And don't be afraid to say no. Do not give in to people's expectations that you will do particular tasks because you are a woman, especially if those tasks revolve around systemic or historic problems for women in science. It is not your job to solve them.
Okay, yeah. Thank you. Something to reflect on. Yeah. In terms of your role in Jodrell Bank, now, I don't know how often you spend your time at Jodrell Bank, but when you do spend your time there, what does an average day look like there?
Yeah, so Jodrell's a strange place. And technically, we're at Jodrell Bank right now. We're at the Jodrell Bank Centre for Astrophysics. So, yeah. So, Jodrell Bank is actually 3 places. So here we're at JBCA, which is the, if you like, the scientific department, the research department. When you say Jodrell Bank, I think you're talking about Jodrell Bank Observatory.
Yeah, cue picture.
So Jodrell Bank Observatory is the facility that is associated with Jodrell Bank. The observatory is a really interesting place. It's super historic, super important, but it's also a cutting-edge research facility. So it's this mishmash of lots of really interesting things. And so if you go to the observatory, you don't know what's going to happen on that particular day. A typical day at the observatory, I don't get out there enough, I have to say. But if I am out there, I will split my time between the observatory itself, which is the Historic Observatory. It's part of the University of Manchester. The Lovell Telescope is part of the University of Manchester. I will be at the observatory. I'll probably be there to talk about computers or data. That's typically why I'm out there. I will also then probably spend part of my time at the Square Kilometre Array organisation, which is located at the observatory. So the Square Kilometre Array is the world's next big radio telescope. And I'll be over there probably, again, to talk about data and computing, but specifically for the work that's going on around that telescope. At this point, the telescope's being constructed, data's coming in, how are we going to deal with the data, where does AI fit into the process, general things like that. And then I'll probably also go over to the Discovery Centre as well. These days, mainly to go to the cafe and the shop.
Okay, yeah. You heard it here first, it's the place to go.
Yeah.
When researching your many achievements, you're one, is it, of 5 people within the Turing AI Fellowship. Could you tell us a little bit about, first of all, what that is, how you achieved such a status, and how it affects what you do now, if it does?
So firstly, the Turing AI Fellows are associated with the Alan Turing Institute. The Alan Turing Institute is the UK's National Institute for Data Science and AI. They have a fellowship scheme, and I was one of the 5 inaugural fellows. So there are more fellows now. But in the first year that they ran these fellowship schemes, I was selected as one of 5 people who was awarded the fellowship. And the other fellows work in different areas. So my fellowship is for AI and astrophysics. And then there's natural language processing, AI and engineering. Actually, so what it meant to me was really important because it enabled me to set up a research group that focused on AI in astrophysics, because that didn't really exist prior to that point. And you couldn't do it through the normal research routes because it wasn't enough astrophysics and it wasn't enough AI to fit into either of those 2 buckets. It was right in the middle. And so the Turing Institute invested in my research as a means to bring those 2 things together. So that was, it was really, really good for me, really pushed my research forward. So that was fabulous.
Brilliant. Okay, thank you. Yeah. Is there anything else that you want to share? University students at the University of Manchester studying all different kinds of STEM subjects, from pure maths all the way to aerospace engineering. Is there anything that you'd want to just say kind of generically to them?
Yeah, I think something that I didn't realise as an undergraduate was the networks that I could make. The University of Manchester is huge, and it has really interesting departments and people working on really interesting things, and the students at all those departments are here. So I think my advice would be to use the opportunity that the university provides and really, really make the most of it. You don't get these opportunities as often as you would think in life, and so it's good to grab them when they happen.
Brilliant, thank you. Hint, hint, come to our events. Thank you very much, Anna. We really appreciate it. This was an interview with an astrophysicist.